All right. So after table, the next object which is most commonly used by developers and DBAs is called as a index. So index are not uh, compulsory object. It is an optional object which is created on a database to make sure that the database works responds faster. So how does that work? We'll see. So assume this is the table which has how much 24 columns. Probably this table is being used for storing information about a car manufacturing company. Okay, so it's storing a information about car manufacturing company. So here it puts what year the car was manufactured, what is the make of the car, model of the car, color of the car, what brand it is, how is the seating inside the car, is leather seating or uh, cloth, or how is the seating, how are the exterior color, interior color, pictures. You can even store pictures in your database, and many other information about the car. So this is the table which they have. Now this company has been running for decades. Say for example, Honda or Toyota, they are running from decades. So they have so much of data in that one table, which is called as a car. Say, let us assume that table name is called as cars. Okay, they might have a table for SUV. They might have a table for what say if they manufacture trucks, they have a table for trucks. So we have multiple tables in their database. Now let us consider this table which is called as a cars. Okay, so this has since that company is running from decades, they will have many rows of data in that one, because there are so many cars people are using for that company. So all that information is there in this table. Now say there was a requirement by some a reporting team who wanted to project that data to their CEO or their manufacturing department, and they say, I need all the cars which had red color as their exterior color and were manufactured in 2020, and which had seating of leather. Okay, now that information will when that particular query is written by the uh, application team to pull up the data, they need to check. So the report says year, I'll just highlight those, year, color, right? 20, in year 2020, color red, the seating has leather, and say interior had interior color was black. Okay, so four conditions were provided. Now for this four condition, what a query will do is it will come and read all the data from this huge table, and it will just pick up the values for year, color, seating, and interior. Now, what did the query do? It read all those 100,000 entries. I'm assuming there are 100,000 entries. So all those 100,000 entries which was there in this huge table, and then it tried to pick up those four columns of information. Then after picking up that information, it will it will dump that information in a temporary table. In the temporary table, it will try to narrow down which all which all rows are for year 2020. It will then narrow down which are color is red, and then it will dump that information in another temporary table, then pull up that final information, give it to the application user who is trying to pull up that report. Now, this kind of gave the database a lot of work. First of all, it had to scan 100,000 rows. Okay, then it had to just pull up these four columns and put it in temporary table and do all those things, multiple things, right? So if you want to make this process little bit easy, right? So what generally developers do is they create something called as a index. So how what is the use of creating an index? If this was the requirement we had, and that requirement kind of comes very frequently, every month they are asking us that information. Okay, for this year give me that information, for 2020 give me that information, for 2020 car color is blue, give me that information. So lot of such requests are coming. So what the application team will do is, okay, we are getting a lot of this request, and this is kind of taking some time to pull up that information from the database. Let's try to make it easy. And what he will do is, he will create a index for these columns: year, color, seating, and interior. Okay, so how does he create that index? By using a command like this: create index. Index name, you can give any name for the index name, just that that index name should not be same as the table name. Okay, so create index, index name on which table? On, say, I'll just update this one. Say our table name is cars, right? I'll say car ind 1. Okay, car index 1 on cars, and use the column name as what were the column names we selected: year, and color, seating, and interior. Color, seating, interior. Okay, so he will say, okay, let's create an index, and let's try to give less work to the database. And he gives us this statement. He says, okay, can you go ahead and create this index on this database? And DBA just copies this statement, he connects to the database as sys DBA, and he runs that create index statement. Now after this, the same query, how it works is, now below this one, we have index which is called as a, below the, so this is a table, right? Cars is a table. Okay, we have an index which is called as a car underscore ind underscore 1. Okay, car index 1. So what this car index has is, it has only information about year, color, seating, interior. Okay, only those column information exist in this index. So there, so when we create this index, it will go and run a query where it will put up all the information of year, color, seating, and index, and it puts in that index. It creates an index. Again, index in the backend, it's a table only. It's saved same information like rows and column only. Just that it has less information from that huge table in an index. Now, when same query is run, database need not read all the data for make, model, brand, exterior, all this information. It need not read. So it will check what all columns are asked in the query, and it will look for an index with those columns. If there exists an index, it will go and read the index. Instead of reading 24 columns, now it is reading only 4 columns. It will read 100,000 rows, that's fine, but you are reducing the work from 24 columns of data, reading 24 columns of data, to reading 4 columns of data. So that is the magic of the index. It will reduce your load on the database at a very high level. And whenever uh, when it comes a point where some query is running longer, the first thing every DBA checks is, what are the columns is it that query is trying to access, and is there any index which can be, which exists already, which database is not using for some reason. And if it does not exist, the first recommendation given would be given is to create an index. There are few utilities which we can use, which lets us know how to decide what exactly to do. Nothing to worry, that is kind of a performance DBA role. We will not go there right now, but there are tools which will help you, and say like, there are tools which will analyze the data and say like, okay, this query is trying to scan the whole table. Instead of scanning the whole table, you can create an index on this columns, and that will help your query performance, right? So that is what the index is basically. Any questions on this? Or you guys got confused?
No confusion there.
Okay. Okay. So third object is called as a view. All right. So let us consider the same example where we have a table which has so many rows and columns, and we have indexes created, but we in the sense application team suddenly realized, when they were analyzing some data, they realized that there is a particular query which comes all the time, and it's asking for same number of columns with same condition. So every time that particular reporting team user comes and asks me to give all the cars which were manufactured in 2020 with color red and seating has leather, right? So he will think this guy is always asking me the same query, so why should I run that same query again? I will create an object which is called as a view, and instead of running a query like so, simple query for uh, this one will be select year, color, seating, interior, where, okay, interior, from which table? Cars table, and the conditions where year equal to 2020 and color equal to red and seating equal to leather and interior color equal to black. Okay, this is the only simple query they will be running. Okay, so while the main point we thought about while creating, so okay, let's go this way. So without index, this was taken say 1 minute to run. Okay, so we checked and we thought a index will create help, so we created an index. So with the index, the query will remain same, the query is not changing with the index, just that internally database will use the index to read the data, and with index this query starts running in 10 seconds. Within 10 seconds you have that information. Now same query is coming every day. Let's say same query is coming every hour. They are trying to generate that report, and they are running that report, and that report is running this query on the database every time, same query, nothing is changing. So what that developer will do is he will create something called as a view. What is a view? A view does not store data. Okay, this will be a interview question for you. Okay, what are the objects which don't store data, or what is the difference between a view and something called as materialized view, which we'll see next. A view will not store any data, like index pulled up that 4 columns of data, created a small table, dumped that data into small table. But view is just this query. So what we'll do is we'll just copy this query and create a view like select sorry uh, create view as, and dump this query. That's it. Okay, create view name we have to give car details one. Okay, I created a view which is car details one as the query which is basically running. So what happens now is every time this report has to run, all it has to run is select star from car underscore details underscore one. Okay, point number one, what we are saving, we don't need to run this big query right away on the from the application. Point number two, this query is behind this view, so your internal processing inside the data will be very less, because this query is already in that cache. Your query is already in this cache, and since that query is not changing, the values in that query are not changing, your the database will be able to find that query here, and that information here, that data here. So all the computation happens just in your instance. Your connection will never go to the data files, which is basically where extra work is done. So all that extra work is saved, and that information, when run on the first time, it gets populated here. From second time onwards, it will just pull up from here and give the information to the user. It does not need to do that extra work. Okay, so that is the use of view. It will reduce the load on the database, because it's not going to scan through all that information inside this query. It has to just go and uh, get that data from this view. Internally, this view will go and run this query, but the way it is designed will reduce the load on the database.
So
Okay.
there will be no duplicates of any tables. It won't happen anytime.
Duplicate of table. See, that is where the schema concept will come into picture, right? So if you
Mm.
have one schema where yeah, so schema one will not have duplicate table names or any object. Schema one will okay, let's put like this. HR schema can have employee table, what else HR does? Paycheck table, index called as employee underscore IDX. This is the index. But HR schema cannot have another object with employee table. It will not allow. When you try to create another object with the same name as the existing ones, it database will clearly say that we cannot create duplicate objects with the same name. But in finance schema, you can create an employee table. Yeah. So it's kind of a, you're jumping from one box to another box. In two different boxes, you can have the same name of the object, but one single box cannot have the same name in there.
Yeah, it makes sense.
Okay. So because this is the owner of that object, and they don't share information unless you set up something which kind of shares that information. Okay, so that is view. Second, how do we create a view? This is how we create the view. Like I showed you, create view, view name as, how did I put it? As, okay, as that query, whichever you want to put that query on here. All right. Next comes materialized view. What is a materialized view? It is same as view, but materialized view stores the data also. So with materialized view, what happens is you are reducing the work even more. So here in view, you reduce the work of analyzing that SQL statement every time, and you are getting that information from the cache, everything. Now, what materialized view does is it whatever the data which was pulled out for that query, it creates a table in the backend and it saves that data also. So just in case if there was any requirement for which it had to go to the data files and get the data, because it was not able to find the data in the buffer cache or the results in the result cache, it will only go and look that one materialized view. It will not go and search that whole table. It will not go and search that index. It will not go and search run that query on that on that view. So if a materialized view exists, then it knows what to check, where to check. It will directly go there and it will check and it will give back the data. So that is the materialized view. So your interview question would be something like, what is the difference between a view and a materialized view? Simple. Both are created in a similar way. Just that Views do not store data. They run the query and give us the information on the fly, whereas materialized view store the data, and they gives us the data from their own master tables, from their own tables in which they have stored the data. Okay. uh, One thing which we need to remember when materialized view come into picture, say I created a materialized view called as cars underscore mv. When did I create this one? Say I created in December 2020, sorry, 2023. Okay. Now in January 24, what happened was they did some cleanup in the table. Okay. January 24, cleanup happened, and somehow on some condition they cleaned up few of the entries where the cars with the red color were deleted from the table. Now your materialized view, which had that information, there the information will be same because it does not go and delete from the materialized view. It will go and delete from the master table where that whole information is there. Now your information in the master table is out of 10, say out of 10,000 cars, say 1,000 was cleaned up because either those cars were trashed or they were retired or something like that. So only 9,000 are there. So this table will give you 9,000. This table will have 9,000 rows, but your materialized view will still will have 10,000 rows because the materialized view ran the query, pulled the data, and saved it in its own table long ago, which was not refreshed. So every time you do some cleanup on the table level, knowingly unknowingly, the materialized view need to be recreated, okay, or refreshed. So again, that is what a developer is for. If he is doing some cleanup, he has to know that after the cleanup I have to refresh the materialized view. When we say refresh the materialized view, it's basically going to check the data again and dump that data in its own table. So that is called as a refreshing of the materialized view. Next object is called as a sequence. What is a sequence? Sequences are basically to generate a counter kind of thing, right? If you want to start counting how many entries, how many times one particular table was updated, say for some say there is an application, or let us consider Facebook. So Facebook has a count where, okay, let's say YouTube, when I upload the video, it will give me a count, like how many videos were uploaded, right? So that is a counter which keeps on incrementing by one every time a video is added to my channel or my account in the YouTube. So that kind of counter which automatically gets incremented, those in the backend are created by this sequences. So we create a sequence and we say every time there is an entry in this table, you increase the sequence, which on the back end is a sequence. On the front end of the application, on the Facebook, sorry, on the YouTube, it will just show that number of videos which are added is increased by one. So that is the need of the sequence object. Then after that, we have something called as a synonym. A synonym is basically um, a synonym is basically a alias. Say your internal company table name is cars. Now that is easy to guess. So if some external hacker is trying to get into your database and trying to pull up this information from your database, then there is a way where you can mask this name. Instead of cars, you can create a alias for that car, like um, what can we do? Vehicles one. Okay. So this way all the information you will show at a public level or the application level is, it will only show like it is pulling the data from vehicle one, but it will not show whether it is pulling the data about cars, it is pulling the data about SUVs or trucks, right? That is where the synonyms come into picture. Synonym is basically another name for an object. Constraints. What are constraints? Basically, constraints are some conditions which you put on the column when you are creating a table. Example for this one would be, while you are filling a form, say you are creating an account on YouTube, Gmail, or anywhere, it does not let you proceed without you enter the email address or your date of birth. So that particular place where it does not let you proceed further without entering that one, there they have in the back end at the table layer, they have created something called as a constraint. They say null constraint. Null constraint means that column cannot have a null value. There should be some value in that column. We can create some other constraints like, uh, uh, if it's a date of birth field, if you are creating a constraint, then it can be like this. This particular column must have only numbers. You cannot put characters, right? So if you are trying to enter July 1st, 2020, then you cannot enter July. You have to enter the month for July, like 07. So those kind of constraints also can be put in at the database level. When you put those constraints at the database level, when the front end application is trying to enroll users by filling a form, it will show the constraint on the application front end also. So this is about the transaction management, how the transaction happen in database, which we have been talking about this all the time. So this is just an example, like when you are transferring the money from your savings to checking account. So what happens, say here we are transferring $500 from our savings account to the checking account. So first it will go and minus $500 from my savings account, then it will go and plus $500 in my checking account, and then it will enter in the backend journals of bank that this transaction happened, and then it will commit the work. When you say confirm the transfer, it will go and commit the work. So basically transaction begins when you initiate the transfer, and the transaction ends when you commit the transfer. So while doing the transaction, database follows some properties called as ACID properties. So this is basically, it makes sure that there is consistency in a transaction. It does not, a transaction is not complete until all of this completes. Okay, so it does not just minus that 500 from savings account then come out of the transactions. No, if it is coming out of the transaction, it will make sure that it rollbacks that changes and comes out. So these conditions are applied on every transaction. Then commit, we have seen commit, basically it confirms that the transaction can be the changes made by the transaction is permanent. Save point and rollback will come later, I don't want to confuse now. SCN number we have seen is a system change number. We saw how we generate how the SCN keeps on changing for the database. Deadlock transactions, we will read this in the performance class. It's better we explain there. Okay, pulling out that information about objects. Now we just saw that we created an employee table, which is an object. We created an index, which is an object. We created a synonym. We created a view and everything. All those are objects, right? So how will a DBA or anybody keep track of these objects? Where do we get that information? So there are something called as internal tables, which database creates default when it creates a database. So they are one of it is called as I'll just show you that columns. DBA underscore objects. Okay, so this is one of the tables which is called as a DBA underscore objects. So in this table, you'll have all the information about all the objects in the whole database. So if I just run select object underscore name from DBA underscore objects, you will see so many objects get returned. So all these are the objects which are created in the database already. This is a fresh database. Okay, all these are default objects, default tables which save some of the other information in the database. So those we have like 72,886 objects in this database. Okay, so DBA underscore objects is one of the table which can help you, and other one is okay. So objects DBA underscore objects, let it be, uh, and there is something called as user underscore objects. Let's see, user underscore objects. Yeah, user underscore objects would be only those objects which are owned by users. Let's see how much it gives. Select object underscore name from user underscore objects. Okay, here we had 72,000. Let's see how much this gives. I think it's gonna give the same count. Okay, less 51,000. So users other than the standard users, we have 51,000 objects in the database. So these are the queries which we generally use to pull out some data. We use this DB underscore objects frequently, the table. So try to remember it somehow. DBA underscore users, sorry, DBA underscore objects. Okay, whatever a DBA will access, most of the times it is DBA underscore. For objects, it's object. For users, it's users. DBA underscore users, DBA underscore objects, DBA underscore tables, DBA underscore indexes, DBA underscore views. So same way, right? Just DBA underscore whatever you want to check. If you want to check how many tables are there, then DBA underscore table. If you want to check how many indexes are there, then DBA underscore indexes. You want to check in general how many objects are there. When I say in general how many objects, I'm talking about all indexes, tables, sequences, everything. In general, all of this you can use DBA underscore objects. So those are the few tables which will have that information. And last one is something called as a dual table. This is the only table in the database, in Oracle database, which has only one row and one column. So that would be just like this, one row, one column. So your table might look just like this. Okay, this is value. What is the value? And this is the uh, key. Okay, so you can use this dual table to pull out some information. If you remember, when we tried to pull out that SCN number, we use this dual table to do some simple calculations. Say 3 times 4 plus 5 divided by 3. You can use that table. It will give output, like it will do the computation for you and it will give you the output. So this value will be there at this location. Okay, this is how your dual table will be when you run that particular query. Okay, and this is also an interview question. What is the table which has only one row and one column in Oracle database? That is dual table. Yeah, so that is it for this database objects. Any questions?
Hmm.
All right.
So now it's looking like when you are saying everything looking very easy, Adil. So when we have to sit and look back, then we might get any questions.
Yeah, that's where let me stop the recording.